Example 13, a cathedral ceiling creates the interior walls shown in the figure. So basically we're inside a house. This is one wall of the house. A cathedral ceiling just means that one wall is taller than the other wall, creating this slanted ceiling. So I don't know if you've ever been inside a house with cathedral ceilings. Typically they've got them coming from both ways. So if you go inside the house, there's like a high spot here where it comes down like that. So this is like one half of the wall. It could just be slanted like that. You know.
That's on my porches.
Yeah, and it's not uncommon, but a lot of houses too, like you'll see houses, they'll have the roof like this, but then they'll put like a normal flat ceiling inside the house, allowing more insulation and stuff up top too. So it depends on how your builder built the house or whatever. But anyway, this is what we're looking at. It says find the length y of the beam needed to go along the top of the wall. So we want the length of this piece here that starts here and goes along here, like so. And if we were to construct a line across, let's make it blue. If I consider this horizontal line, creating this rectangle here, we're going to assume it's a good, well-built house, so this is a right angle down here, this is a right angle over here. That's 8 feet there, which means this 12 feet is split into 8 foot there and 4 feet here. This is also a right angle. And then the bottom figure here, right angle, right angle, right angle, right angle, makes it a rectangle, which means opposite sides congruent. So 8 feet, 8 feet, 22 feet, 22 feet. And our task is to find the length of y, the beam. And what I've created here is a right triangle where I know leg 1 is 4, leg 2 is 22. I want to know the hypotenuse of the right triangle. And in general, anytime you're looking at a right angle and you know two sides, the Pythagorean theorem can be used to find the third side. So, Pythagorean theorem says the hypotenuse squared, which is what we don't know squared, equals one side squared, one leg squared plus the other leg squared. So y squared should equal 4 squared plus 22 squared. Next thing we do is we square 4, which is 16. We square 22, which is 484. All right? Mm-hmm. Okay. Add them together, I get, well, this will be y squared equals. So add them together, get y squared equals 500. So y is going to equal the square root of 500. And again, a couple decimal places for the answer, doesn't specify. So if I grab my calculator and punch in the square root of 500, comes out to 22.36 feet. So that's just an application of right triangles. Again, right triangles in general, Pythagorean theorem, when we know two sides out of the three. In a 45-45-90 or a 30-60-90, we have these special relationships that we saw in the first two examples in this section. A 45-45-90 right triangle relationship is 1, 1 square root of 2 for the three sides. In a 30-60-90 right triangle, opposite the 30 is 1, opposite the right angle is 2, and opposite the 60 is the square root of 3. So you want to commit those two triangles to memory. And again, if you have a 30-60-90 or 45-45-90 right triangle and you know at least one side, similar triangles can be used to find any missing side in that picture.